Our next task is to plot a prediction grid. This means that once we've observed our data, we can examine some part of the predictor space and compute the class prediction for each point in the grid using the KNN classifier. So instead of finding out how our classifier might classify a given point, we can ask how it classifies all points that belong to a rectangular region of the predictor space. We'll go through this example fairly quickly, but I will explain mesh grid and enumerate at the end of the example in a bit more detail. We'll be writing a function called makePredictionGrid, and it will take a number of different arguments. We'll be filling those in as we go along. We'll start by specifying the x values of our grid. So these are the x's. We'll be starting from x min, we'll be going to x max, and we'll be using increments of h to do that. In a similar way, we'll be creating our y's. We start from y min, we go to y max, and we'll be using the same step size again. Then we'll use the numpy mesh grid function, which takes in our x's and our y's, and it generates two two-dimensional arrays. I'll be calling them xx and yy. This is the function that I will explain in a little bit more detail once we're done with the example. We need to provide the values of x min, x max, y min, and y max to this function. The user will be providing what I call limits. It's going to be a tuple, and we will just unpack that tuple to get the values of the variables we need. So x min, x max, y min, y max. So limits will consist of 4 elements. So limits will be a tuple in this case. We now have the limits of our grid. We've generated our x vector, our y vector, and we have the mesh grid generated. We next need to generate our classifier's prediction corresponding to every point of the mesh grid. We'll be calling this object prediction grid. We'll first fill that with zeros, and it's going to be the same size as xx or yy. I've also specified that the data type is integer because we know that the class label is either 0 or 1. We'll then be looping over all of our x values, all of our y values, asking our KNN predict algorithm or function to predict the class label 0 or 1 for each point. Once we've done that, we want to capture those predictions in our prediction grid array. Let's first loop over our x's. In this case, I'll be using the enumerate construct. Again, something that we will discuss briefly after this example. We're looping over x's first. Then we need a second for loop, which enables us to loop over all of the y values. Again, we'll be using enumerate to do that. We now have our x and our y values, and because we're using enumerate, we also have the corresponding index locations in the x's and y's vectors. We'll be generating our point P, which is a numpy array, and it consists of 2 points, which are the current value for x and the current value for y. We then need to predict the outcome that is associated with this given point. To do that, we'll be using the KNN predict function we wrote before. We want to predict the class label for point P. We need to provide our predictors, our outcomes, and the value of k. The specific value of k here is the k in the KNN algorithm. That means that's the number of points that will be considered when making the class label prediction for point P. We also want to make sure that we capture or retain these predictions. And we'll be using a prediction grid for that purpose. We'll capture the prediction by the assignment here, and we're more or less done. Let's go back to our definition of the function here. We know that we need to provide predictors as an argument. We also need to provide outcomes. We need to provide limits, which was our x min and y max and so on. We need to provide our step size. And finally, we need to provide the value of k. Let's also put in a placeholder for our docstring. And let's make sure we return the objects that we've generated. So we'll be using the return statement. We want to provide xx, yy, and prediction grid. Finally, let's complete the docstring. We'll be providing classify each point on the prediction grid. In other words, this function will run through all of the points on our prediction grid and will predict the class label corresponding to that point. Finally, before we move on, let's look at the assignment of our prediction on the line where we say prediction grid ji equals knn predict and so on. Note that we're doing the assignment j, I, not the other way around. This is because j corresponds to y values, and when we specify an index using square brackets, the first value, the first argument, corresponds to the row of the array. That's why we want to make sure that we will assign the y values to the rows of the array and the x values to the columns of the array. Let's run our function. And so far everything looks good. Let's look at MeshGrid in a little bit more detail. MeshGrid takes in two or more coordinate vectors, say one vector containing the x values of interest and the other containing the y values of interest. It returns matrices, the first containing the x values for each grid point and the second containing the y values for each grid point. Let's look at this on the whiteboard. To construct a mesh grid, we first provide an array of x values, which would be these numbers, say 0, 1, 2, 3, and 4. And then we also provide an array, one-dimensional array of y values. Let's say 1, 2, 3, 4, and 5. So these numbers here are the first argument x, and these numbers here are y, our second argument. We don't necessarily have to have the same number of points in these arrays. What MeshGrid does is the following. Let's extend these ticks. So we generate a full table. Let's look at a given point on the grid. For example, for this specific point, the coordinate would be 2, 4. X is equal to 2, y is equal to 4. If we look at this point over here, the x value is 1, and the y value is equal to 2. We could proceed in a similar way and attach a coordinate to every single point on the grid. This is precisely what MeshGrid does. The first output that it provides is going to be the x values of each of these coordinate pairs. The second output is going to be the y values of all of these coordinate pairs. This is why we need two output matrices, one matrix or one array containing all of the x values and another one containing all of the y values. Enumerate is useful when dealing with sequences and when we'd like to have access simultaneously to two things, different elements in the sequence as well as their index values. Let's look at this example from python.org. Let's define seasons as a list of strings. First we can have spring, summer, fall, and winter. We can generate an enumerate object using seasons. Let's first define seasons. Now if we run the code here, Python will generate the object, but we don't actually get to look at its content. So to do that, we can first turn it into a list so we can actually take a look inside what's going on. Enumerate returns to us a sequence of tuples. Inside every tuple, the first object is going to be the index that corresponds to a specific object. The second item is the object itself. if we look at the output, we can see that the first tuple consists of 0 and spring. The second one consists of 1 and summer, and so on. We can illustrate this in a for loop. We say for index ind, season in enumerate seasons, we can print index and season. And this is an example of how we can use enumerate.